It's like
tough.
Joseph Nelson as J.R. Bob Dobbs, the patron saint of Church of the Subgenius.
Hello, everybody. Welcome to OpenCV Weekly Webinar. And today we have a very exciting episode with Joseph Nelson, who is the CEO of Roboflow. We're going to talk about, is AI smarter than a toddler? Quick intro, Joseph.
Happily. Hey, everybody, Joseph, happy to be here this week. As Satya mentioned, I'm the co-founder and CEO of a company called Roboflow. We make computer vision developer tools, but we also run a lot of experiments to advance and test out state-of-the-art computer vision and machine learning technologies. And so today we'll introduce the challenge with a bit more specificity, but today is one of those days where we can pull back the curtain on some of our experiments and compare how powerful machine learning really is.
That's great. And also with us is Phil Nelson. Phil, we just decided on a new title because Phil was doing way more than what the previous title was. So Phil is now the director of content, but I know there was another piece to it.
Director of content and creative, I think, is what we came up with.
All right, director of content and creative. Welcome, Phil.
Yeah, hey everybody, once again it is I, the co-host with the co-most, the second banana who is second to none, your plus one and only Phil Nelson, and I'm here to remind you of a couple things we do every single week here on OpenCV Weekly Webinar, one of which is our special giveaway to you in the audience. Joseph has been so kind as to volunteer a few things from Roboflow. Would you like to tell people what they'll win if they answer our trivia question later, Joseph?
2 potential prizes for 2 lucky winners. So one is a Roboflow swag pack, which includes things like a Roboflow water bottle, kind of a raccoon backpack, some super cool shades.
Pretty cool sunglasses.
Phil is demoing for us.
You can get a look at the command center here.
And a number of other things. They've been quite popular, and we give them out to our users that build amazing projects and share them publicly. And kind of contribute back to the community, as well as those that are part of today's webinar. And then the second thing that we have for anyone in the world is sponsored increased GPU credits to train bigger, larger models completely for free within the Roboflow ecosystem.
Yep. Thank you, Joseph. And we'll also be taking Q&A from you in the audience. So please use the Zoom Q&A button at the bottom of your screen there to ask your question at any time during the webinar, and we'll get to them as time permits. Satya?
All right. So yeah, this is going to be an exciting conversation, and please, we want you to ask questions, and we are going to answer anything you ask in the chat. Joseph, it's your show.
Awesome. I'll share my screen here to get things started.
Excellent.
How's that look?
Looks good.
Awesome. So the topic of the day is machine learning smarter than a toddler? And Phil didn't make me change the subtitle, so I said it's at least smarter than Phil, which is a nice way to kick off.
Accurate.
Nice way to kick things off. And I said I didn't say the toddler or machine learning, so we'll never know. So as noted, Joseph Nelson, CEO at Roboflow. I'll give a broader introduction to Roboflow, and then Satya from OpenCV coming at you live with today's discussion. I like to introduce OpenCV. I know it's your all's webinar and you feel sort of strange describing it, but it's a pretty cool opportunity to describe like the impact that OpenCV is having. So I always like to lead with this context. Satya, if you want to give us the 30,000-foot view of all the work you do.
Yeah, so OpenCV is the biggest computer vision library in the world. It has more than 2,500 algorithms in it. And since the last few years, we have started growing beyond the library. We have courses now. We have OpenCV AI Kit with Depth, which is a very powerful spatial AI camera. And we also have ModelPlace.ai, where we have a repository of many state-of-the-art models. We do benchmarking, etc. And of course, we also provide consulting services. So that's OpenCV today. We are growing fast, and we'll see how it goes. And we've been doing a lot of community activities like competitions, which have been very popular. So that's where we are today with OpenCV.
Wonderful. Yeah, it's been great to be a partner in OpenCV. A lot of folks use OpenCV and Roboflow together, so it's always been a very nice partnership to describe and democratize access to some of the more traditional algorithms that OpenCV has powered for the last 2 decades, and in the transition of machine learning and deep learning based approaches to computer vision. So a little bit about Roboflow for those that are unfamiliar. At Roboflow, as I mentioned, we build tools for adding computer vision into your products faster, more efficiently, and more accurately. So a little over 50,000 developers build with Roboflow. And actually, in fact, developers from over half the Fortune 100. We're fortunate to count customers like Walmart, Cardinal Health, the Medtronic, and some other large companies, just as much as many small companies and startups that are just getting up and going. And across the globe, customers from Taiwan to London to New York to San Francisco and everywhere in between. We are ourselves a remote distributed team, predominantly based in the US, with a couple of folks in Canada, but so mostly North America. And we predominantly build systems, as I mentioned, for developers to add vision to their products. To be a bit more specific, if you're building a computer vision model, you need to ensure that you have a high quality data set and be able to collect that data effectively and easily. So we have APIs for smart data collection, identification from video and image feeds, organizing that data. So what data do I label? How do I share it with my team? How do I make sure that I'm working on the right sort of data to improve my models? Labeling of that data, so you can actually label directly in Roboflow for object detection, classification, multi-class classification, instant segmentation, which I think is new since the last time I was around these parts of having segmentation support. And then you can train models as well directly in Roboflow. So if you want to train a model, you can use that for automatic labeling. You can use that model and host it via API. You can deploy it directly to the edge like a mobile device or an Oak device, the OpenCV AI kit. And then you can monitor the performance of that model and kind of repeat the loop, because as the folks that are in the machine learning world know, it is super key, not just to deploy a model once, but continuously improve. And in a lot of ways, the data is going to be changing. So having a system for continuously improving that model is important. There's been all sorts of cool use cases that have been built with Roboflow. Some of the ones that I like to talk about are things like Wimbledon using us for like powering their instant replay, and then hobbyist sort of the projects as well. Like, I don't know, I think some of the one of the most recent fun hobbyist ones that I came across was, if you know, like the game Cornhole, or some people call it bags based on the regional geography, someone was using an Oak device with Roboflow to build like an automatic like cornhole scoring device, which is just in time, right as football season's around the corner and tailgates will come out and you need to automatically score your cornhole. So
yeah, do people who don't live in America know what cornhole is? I don't think they do. I do not think they do. It's basically, I'm gonna get a ton of hate mail for this, but I think it's a crappier version of horseshoes. I said it.
Wow. I'll be the first hate letter right here.
So basically, you've got this cardboard or this wooden plywood thing at an angle. You stand like 10 feet apart or whatever. Is that what it is? And then you try to throw little bean bags into the hole in the middle. 2 people per team and whatnot. It's basically crappier horseshoes. I'm not taking that back. Anyway, continue.
Maybe a more international relatable one was someone was making a foosball scoring model. So every time the foosball goes into the goal, they want to automatically score that had happened. So there's people that are doing that stuff just as much as household name car manufacturers that are improving their production lines with Roboflow. So everything in between, it's been really, really exciting. One thing that actually I should share is, let me come out of screen share for a moment. We've actually launched something that I'll drop the link in the chat for everyone to play around with, that makes it much easier to discover the public projects that many creative users are building with Roboflow every single day, called Roboflow Universe. So
we should do that for OpenCV.
Yeah,
I've checked it out. It's definitely I get your marketing emails, obviously.
yeah. So like on Roboflow Universe, for example, if you want to do something like, I don't know, let's say we're building like that tennis ball outside project, you could go ahead and see like other users that have worked on similar projects, and that can accelerate your ability to build models and get things up and going a bit more quickly. So this has been very, very popular.
Great resource if you're getting started as well. You know, a lot of the teams in OpenCV Spatial AI contest, which we just announced the winners for last week, got a lot of help using Roboflow for their projects.
Yeah, so I think Roboflow was the most popular tool for people who had no experience with AI. But I think it was also very popular among people who just wanted a more structured platform where they could easily try out different experiments.
It holds your hand a little bit more than some of the other systems.
And also the data is there and everything is there, so it makes it very convenient.
Yeah,
absolutely.
Our goal is generally to be a nice on-ramp for folks that are just getting into it, just as much as having that deeper level of sophistication for folks that need to improve models and know what data to label and these sorts of things. But I mean, like, kind of a fun Pepsi challenge is like, I don't know if someone wants to put in the chat like a topic that they're like, I wonder if someone has built a computer vision project to do blank thing. It's kind of a fun challenge.
So my project that I've been threatening to use Roboflow for a while is video game cartridge identification and labeling. So let's see what we got.
Wow, that's very specific.
Oh,
you got plenty of those too.
Look at that.
Interesting. Ooh, yeah, I like that.
This one actually looks like it might. I mean, these games are probably a bit more modern.
Is it doing segmentation, or is it doing just detection, or is it also running OCR? Because that would be incredible. This looked like, yeah, there we go.
Yeah, PS2 it looks like.
Yeah, the next step obviously would be
some angle bounding boxes for you and everything.
Fancy.
Yeah, that's great.
Yeah, great starting point.
So yeah, anyone that's actually Ritesh, I think, has been on the webinar. He's made models with like blackjack card detection and things like that. And you can actually go ahead and use that model right out of the gate.
Yes, indeed.
So yeah, that's a bit about what's made it possible. And as discussed, it's a developer tool. So free to get started, start using it in your projects and get live. And then if you're a private company and you're working on private data and you want to be continue to be private and you want to grow out of the sandbox, then of course we have commercial offerings as well. But here's kind of the way we describe the product: everything from collect, organize, label, process, to train, deploy, and monitor improvement. And usually folks kind of like, they'll either kind of like get deep into some of the data set organization and maybe they want to do some of their own training. Or there's folks that say, the ease with which we can do all steps of this process in one place is very, very helpful. So that's kind of where it depends on the depth and experience and where someone wants to be customizable. But it's pretty interoperable with existing tool chains. So yeah, it's been a lot of fun working on this. And what we're talking about today has little to do with the core tool chain, which is why I thought it was important to share a bit about the context of where this comes from. Shifting to the flavor of the day discussion. So today, I want to have a discussion of comparing the state of the art of machine learning versus toddlers. And that's sort of like a strange topic. Like when I messaged Phil that I thought this would be a fun thing, he was like, I don't know about that. And eventually, he's come around, and maybe to his dismay, we'll see how.
Well, that was after you told me that it wasn't about how many toddlers a Terminator could defeat in battle.
I never said. This was never stated. And so I think that, like, given some context for the motivations here of why this is an interesting topic is helpful. I mean, for starters, artificial intelligence has its roots in emulating human capability, right? If you consider the Turing test of, can a model fool a human into whether that was a human motivated outcome or was a machine learning system that came up with a given outcome. And benchmarking how far machine learning has come from state-of-the-art model advances versus human intelligence is always like a fun ongoing endeavor. And I think few things are more fun than kind of comparing how models learn to like how like childhood development and like parenthood, some of these things come to life. So I think it's kind of like a fun general moment of intrigue, and in some ways kind of like philosophical of like, man, like, do these models possess consciousness? How much do they really know? Like, and these sort of questions that get asked.
I always think, this is an aside, but I always think that watching kids grow, it's almost evolution in the miniature. So for example, they learn to walk first and talk later, right? So maybe it is related to evolution that we as humans started walking first and talking later. I mean, there were other means of communication, but language required more sophistication, right? That's an aside. Whenever I think about toddlers and learning, that is something that comes to mind.
Yeah,
Completely.
definitely. The order of learning.
And some additional motivations for this. So Francois Trollet, he's the creator of Keras, the popular library that has since been merged with TensorFlow, not an April Fool's joke, actually merged with TensorFlow. Of wanting to, he wanted to, in 2017, he kind of had this tweet where he said, you know, there's no practical path from superhuman performance in thousands of narrow vertical tasks to the general intelligence and common sense of a toddler, which I think actually tees up the discussion of machine learning versus toddlers in a really effective light, because machine learning and artificial intelligence, as we know, is quite good at narrow AI tasks, right? Like you've seen systems that diagnose cancers better than like state-of-the-art doctors on very, very narrow tasks of, say, here's an image of melanoma versus not. And these systems learn and pick up on subtleties that diagnose conditions in a superior way. And the question that I'm kind of interested in asking isn't just like maybe the narrow tasks, but like in a general sense, in the idea of maybe like almost memory and zero shot capabilities. And if we just took some of these large mega models and we said, hey, I'm going to have you put you up to a given task, how well can you do compared to what a toddler might do? And I think that's kind of the way that I wanted to frame the discussion today. And I'll unveil some of the challenges of what we're going to compare into the models and like the human intelligence tasks. But I thought this was a good point for discussion of, Satya, if you had thoughts about like the idea of like narrow AI and general AI and kind of how these tasks all come together.
Yeah, so the first thing I want to say, even before getting into that topic, is that we always compare machines to humans, and not just one human. We want to compare it to the best human possible, right? Or you want to play chess, it's not enough that you're beating 90% of the population. Can you beat the best, right? So you put a very high threshold on these machines. And the second thing is that you always compare machines to whether a machine can do a human task, right? So it is the human's capability that you're comparing against a machine, not the other way around, right? You never say that, oh, can you actually memorize a telephone book, right? Because that's a machine's job. Machine does it very well. Humans pretty much suck at it, right? So it's very unfair to machines when we talk about, oh, are you as smart,
or like the baseline human is sort of what we're talking about, right?
Well, we are all the assumption is that humans are smarter than machines because we are judging machines on human tasks. But if you flip it around, if machines were to make this argument, they would say that, oh, can you actually memorize an address book, right? That's the task we are going to judge you on. Oh, humans, you don't perform that well, right? A toddler, adult doesn't matter, right? We beat you. Oh, you want to, I want to judge you on how your, not peripheral, but back vision looks like. It's zero, you cannot see behind your back. But me, a computer, I can have, 360-degree view with cameras. And if you judge you on that task, then, a machine, even a mediocre object detector would do much better than humans, right? So that's one thing. So there are two things, right? First of all, we judge machines on human tasks. Second thing is that we judge them compared to the best humans. So Toddler is a good one because usually we judge them for the best humans. So in some sense, machine learning has far surpassed toddlers in certain tasks. We just don't judge them on those tasks.
The machines do lag behind in adorableness, I will say this.
Okay, and now coming to AGI versus the artificial general intelligence versus it's a very controversial topic. If you go check out what Jan LeCun has to say about it. Even humans don't have general intelligence, right? There's nothing called general intelligence. Humans are trained for very specific tasks. They are good at very specific tasks, but they are not really generally intelligent, right? So he thinks that we will get to human level intelligence, but not what we call general intelligence. So there's a bit of semantics there also. people, it's a not well-defined term what artificial general intelligence means.
I think there's also something to be said about, people talk about this online a lot, especially lately, but smart versus clever, and how it's a subtle but very important difference. There's a lot of smart machines, but there's not very many clever machines because they can't come up with stuff on their own without being boxed into very specific parameters.
Imagination.
I find that a lot of these discussions do end up in like a place of semantics to your point of like, what do we consider general and whatnot. Now, I do have one more motivation for why I thought it'd be interesting to compare machine learning versus toddlers. And that one is a personal motivation. So I recently, one of my brothers was, or had their second child. And before they had their second child, I was proximate to them in the area. And so they said, will you come watch our first child while we go off to the hospital? And so I went over and watched Griffin, who's 14 months old. And when I was taking care of him, I went through some of like the books for like story time and some of these things. And one of those books that we went through is, I think I might have put it out of order. Yeah, here we go. One of those books was called First 100 Words. And so inside this book is basically a bunch of photos with labels for those photos of like, here's like a truck, here's like grapes, here's like a tomato. And so I, of course, working in the field of computer vision and machine learning, I'm like, this is just mostly a machine learning task that we've got going on here, except with with my nephew. And so, throughout, as we're going through the story, I kind of ask him to point out some of the examples. And I say, hey, can you point out to me which one's the fire truck or which one's the grape or the tomato or these sorts of things? And that got me thinking, if he's able to do it I'm not going to tell you how well he did yet. If he did it roughly at this level, how well would a, state-of-the-art general, I'll call it, at least like a large mega model do at the same sort of task? And that kind of got me thinking of like, if I were to create the ultimate scorecard, if I were to put together a few tasks of comparing, what a general, maybe toddler would be capable of compared to like what some large mega models are capable of, what would the results be? And so that's kind of what I did for today's discussion. And I think it's an interesting conversation to be had about the state of machine learning compared to that of, a 14 to 24-month-old baby as they grow up. So the first of those, or there's three areas that I think we should benchmark against and take you down this road, Satya. So one is object detection and recognition. And I'll talk more about the model and what we're going to use for that in a second. The second is drawing a picture, which I think is like a fair playing field for a machine and intelligence and creativity versus that of perhaps a toddler. And then the first is like maybe completing a text prompt or maybe like call and response, or you can consider this maybe Q&A or something like this, which I'll show something that we've built at Roboflow that uses GPT-3 for sort of a fun sort of project. So I thought, we would compare against these three areas. And, I'm not going to necessarily render a decision. Maybe we can let the audience make a decision about what they think is the ultimate conclusion of the victor or not. But I think this is kind of a fun way to this isn't just like a literature review of let's go through state of the art. It's let's get our hands on and look through and play with some of these models and see what's possible and discuss and deliberate, what goes well and what doesn't go well. So those are the three tasks that I've teed up. I don't know what you think about it, but just say the word and we can start to dive in.
No, that's great. I think these are really good choices.
Awesome.
Yeah, you vetoed the fist fight that I wanted to have as number 4, but whatever.
I don't know that I have a fist fighting robot, but that's not a challenge. Okay, so let's go ahead and start with task number 1. So actually here, I'll introduce Clip as task number 1. So task number 1 is object detection and recognition. So the goal here is, if we say from like the Baby First 100 Words book, for example, which I have a bunch of examples of Baby First 100 Words here. Okay, so Baby First 100 Words, the various pages in this show different objects, and you see these objects are pretty clearly labeled. And as I thumb through this book, certainly those in the audience are like, oh, of course, the machine learning guy saw this as a machine learning task. I mean, just look at this. It's just exactly like labeled images and everything. By the way, this specific page is very challenging for toddlers because this is like describing actions of other toddlers that are labeled in this way. This one was a particular challenge.
But yeah, it's got to be tough when you don't have any sense of self yet.
This book is also a great example of how humans suck at certain jobs, right? For example, if you ask any of your friends, especially the ones with kids, right? Which is the book you have read the most? They would come up with whatever their favorite book is. I've read it 3 times, 4 times, whatever. Maybe I've read it 6 times. But no, the right answer is that you have read your kid's book 100 times every night for what music have you read, listened to X number of times. It would be some kid's nursery rhyme that you have probably, a lullaby kind of thing that you have probably heard
or
1,000
or more
times.
likely these days, something from Frozen or whatnot.
Oh God.
So yeah, that's probably true. Or even just keeping counts. The model would probably do better if keeping counts. And so my thought was, I have this data set, and there's a couple of different ways we could approach this task, right? So one of the ways we could approach this with machine learning. So one of the ways we could approach this task with machine learning is we take all these images and then we drop them, we crop out, like just the ball, crop out just the duckling, crop out just the flower, crop out just the pear, and we drop them into a data set, and we train a narrow specific object detection model. Use YOLO V5 or YOLO R or faster RCNN or one of these models, and we see how well does it do. Now, you'll note if you're in the machine learning field, only having one image per each of these, that'd be relatively challenging. Now, one thing I'll note is that like a tool like Roboflow, you can augment and increase the number of images, so you'd probably do a little bit better, and maybe even deliberately overfit on the training data for the case of this task. But one task that we could do is train a narrow AI to recognize each of these objects. And when I did that, it did quite well, and I'll share and kind of showcase the example data set. But the other approach I wanted to take was, if we took a mega model and we say, does that mega model, when I say mega model, I mean like a very large, and I'll introduce the specific mega model in a moment, a mega model, and we use 0-shot inference from that model. So in other words, while one approach says, I'm going to take all these images and train a specific model on those examples, the other approach says, well, let's take a generally intelligent model and ask that generally intelligent model, does it have the concept of a ball, of a duckling, of a tricycle, of a rabbit? And I thought that was perhaps more representative of interacting with a human, where you're like, hey, do you know this? Do you know that? And so that's the approach that I wanted to take. Now, with that approach, however, just asking it where in this image, you'll realize that like if I just give the model this image and I say, white rabbit, what I would have to challenge it to do is I would want it to crop and say, this is where I see the white rabbit in the image. And so I put together a Colab notebook that I'll show you in a moment that goes through a 2-stage process to output this given task. But that's kind of the way that I thought about this. So at the highest level, it's in this given first 100 words book, Toddler, ask the toddler to identify the object, compared to machine that has not been trained, not a narrowly trained model, just a general model trained on lots of objects out in the world. Can you identify, if I ask you, where is the blue ball on this page? So basically, it's kind of like a crop challenge of, here's the object, show me where on the page this object is. So that's the way that I've kind of teed this up, if we have thoughts or questions about that.
That seems like it makes sense to me. Thoughts, Satya?
No, that makes perfect sense. I like that, how you have thought through this.
Awesome. Yeah, but well, thanks, because I can't change it now. So the model that we're going to use for like the general recognition is CLIP. So what I'm going to do is take a just a generic object detection model to identify objectness of like, see where you see objects that are of interest from just Coco. And then of those objectness objects, I'm going to ask CLIP to say, hey, I'm going to give you a text prompt, and you're going to tell me where in all those objects that were found, where you found the set of pixels that correspond. So basically what's going to happen is the image is going to go through a generically trained object detection model. That generically trained object detection model is going to spit out where it thinks there's objects on the page. So it might find the same one twice. It might find the same one a bunch of times with slightly different pixel boundaries. And then I'm going to take all of those, you can almost think about those like cards. And then I'm going to ask CLIP, and I'm going to say, I'm looking for the white rabbit. Where on the page is the white rabbit? And what CLIP is we talked about this in our last discussion, is it's a multimodal model that understands the relationship between images and text. And so you can kind of give these text prompts and get back image examples. And there's another model that I have on this page here that's called Florence. That's even more advanced than CLIP, but not generally available from the Microsoft research team yet. But the cool thing about Florence is that it was actually trained using images from Roboflow Universe. So researchers are advancing state of the art from images that are out in the community. They created like a basket of public data sets, of 11 public data sets from Roboflow. You can kind of see on the right of like a thermal image of our chess piece data set that's sort of all over the place, packages, and these sorts of things. So that's the way that
the best performing model right now.
Yes, that's the current state of the art. So, okay, so I've pre-run this Colab notebook, and you can see that I've loaded in. This is just me loading the page that you just saw from the first 100 words book. So I've loaded in this image, and then I've printed out the ability to see the image, and you can see a nice human hand there. And then what I'm going to do is I'm just going to grab YOLO v5s just from Torch Hub right out of the box, and I'm not going to do anything to it aside from run it. And what I'm going to do is, so this is me loading YOLO v5, and then what I'm going to do is I'm going to ask it to just look for anything that it might see as like objectness, like things that look object-like from the COCO data set. So this common objects in context, anything that you could see that might potentially be an object, I want you to pull it out of this image. And so that's when it pulls out a bunch of these potential candidates, and it says, hey, these might be some things that I see that are object-y in this image. Once I have those images that kind of look object-y, I'm going to ask CLIP to kind of give it a description and then pare it down and say, hey, I'm looking for one specific thing. Like in this case, the search query, we could say, you know, a person or a flower, a pear, etc. And then CLIP will grab from all of the cards found above up here, it'll grab the one that it thinks is most similar to that text prompt. So that's what we're going to do. I've already run this notebook once. Let's see if the kernel is still alive, as I ran it just before the webinar. Yeah, it looks like it's happy. So if I try, like, I say point to a green pear, and that's my search query. And I say, grab the top similarity to that search query. Where in the image do you see it? There you go. It found the green pear on the page. Maybe I could, I don't know, what else do we want to look for here? Let's say find me maybe the animal. Let's say find an animal. That'll be my search query.
Does it do a bird?
Let's see if it has a concept of bird. Oops. It's kind of funny. You can see like the model thinking as it processes.
Oh, that's neat.
It's pretty impressive. Pretty good out of the gate.
And you're using pretty much off-the-shelf things to do this experiment.
Yeah, I think you said right. YOLO 5S, Coco. What other stuff is Colab, obviously, to run it here.
Yep, and then CLIP, and then CLIP just says it converts my search query into the corresponding images.
So far, so good.
Someone says find an eye. So let's see, an eye. Let's see that in the chat. Feel free to put suggestions out. Let's see what it thinks is most similar to an eye. Now remember, it's looking for from the examples that have objectness.
Yeah.
It's looking from those examples what is most similar to the text prompt.
Is it just one page or all the pages?
This is just one page. Oh, okay. So interestingly, I thought the hand was most similar. Obviously, we could loop through and do all the pages, but given the amount of time you see one page takes to do the search, I thought we'd limit it for the time of the webinar.
Makes sense.
Right. How about a fruit?
Yeah, let's try a fruit. Let's see. Someone says penguins. Oh, yeah, it knows fruits. Let's say penguins. Let's see what it thinks is most similar. So clearly there's no penguins here.
Yeah.
So, I didn't get to ask my nephew find the penguin when there wasn't a penguin. So I don't know what the I don't know what the toddler would do with that prompt.
That's a big problem with your methods here. You gotta have some failures in there, some purposeful failures.
Yeah, let's see. Motorcycle was a suggestion. Let's do motorcycle. Let's see which of these objects here is most. Well, let's get out.
Here's another one. We can ask it. Why don't we ask it to find food and find out if the algorithm is vegetarian or not?
That's funny. A motorcycle. So I think the duckling is most similar to motorcycle. So let's let's say
that's the only one that is mobile.
It's got two wheels.
I should be asking you guys to tell me what you think the answer of most similar.
Oh God, food.
This is actually, kind of pushing the boundaries here.
I feel like it was Crunchy Chicks was the
Oh no.
Oh wow, it's a cannibal. Well, it's not a cannibal, it's a robot. Well, we created Skynet. Sorry, that was our fault. We've just brought on the end of the human race. Darn it.
It's a pretty interesting outcome. It's a pretty interesting outcome indeed. Yeah, so I could get in here and change right now the threshold, if I remember correctly, the threshold of that I had saved.
I believe the phrase that I've heard in the past is long pig.
Long pig. Let's say garden.
A couple folks are asking if you're planning to share the collab notebook, Joseph.
Yeah, very happy to share this collab notebook.
Cool. We'll put that in the show notes as well.
Awesome. So here I actually, when I load the model from TorchHub, I've got I can set the model confidence even lower so that like the number of things that are being called out here and the objectness, it'd be even less picky. So it'd have more potential cards to sort through. So I'll reload. So let's set the confidence level to like 0.01. And so this will pull even more stuff from that example page that I just ran above.
Oh, it looks like we got quite a few.
Yeah. So to give some context to what's happening here, what I said is from this generically trained object detection model, I set model confidence very, very low. So anything that might be an object. Before it was set to 0.25 by default. So anything that's 25% confidence is an object was being found. So now I said, anything that you think could potentially be an object at 1% confidence, spit it out. And then we're going to have clip filter through even more noise. So the goal here is that we would get even more of these on the single page that I loaded. I just loaded this page to be clear of the color paints, the orange fish, the yellow duckling, the purple tricycle, pink flower, green pear, blue ball, black buttons, white rabbit. And so it's finding all of these options. And then it'll print those out below. So there's some questions in the chat. So I should also mention that to specifically train YOLO V5, we also have a cat. Oh no, it looks like my kernel might have died. Okay, so I might just restart this and then come back to it.
Yeah.
Come back to it in a moment. Okay, hopefully that runs happily in the background. Awesome. So
we could take this moment to do our giveaway.
I'm happy to.
Let's we'll pause here and do our giveaway at it's about 9:45.
Let's do one of the two. Let's do one of the two.
Yeah. So our giveaway here will be for U.S. folks only because it's a physical item and it's a huge pain to ship stuff around the world currently, as some of you may be aware. So the way this works is I'm going to ask a question that I've generated from the presentation so far, and you in the Zoom chat will answer. US only. Please, if you've won in the last couple of months, don't answer. Give other people a chance to win. Get ready to answer. We're using a piece of software, a technology here called Clip to build this demo. What does CLIP stand for? Go ahead and answer in the Zoom chat if you know. If you don't know, probably don't answer. It's a tough one to guess.
My kernel keeps dying, so it might be the...
Man, I don't see any answers here. I don't think anybody knows. Did I finally stump him?
Of course. That's allowed.
Zach's got the right idea. He's frantically Googling, according to the chat here. David suggests cornhole something. Okay, good, great guess.
Ah.
All right, looks like if somebody finally got there, they had the fastest DNS lookup to Google, I guess. I see Matthew Schrant. Congratulations, Matthew. Go ahead and send one email to phil@opencv.org, and we'll make sure that you get your Roboflow swag bag, courtesy of Roboflow. Thank you, Joseph. We've also got one more giveaway to do here, so stay tuned.
Cool. So I'm going to let that kernel run in the background, hopefully, and we'll come back to it and have even more images to look at and filter between. That's actually why that's why I didn't want to mess with the comment threshold. I thought we might get an overloaded notebook, so we'll see if we can get more of those alive. Cool. So the second task that I'll go through the second and third tasks relatively quickly. I don't have as interactive of demos, but I can talk about the technologies that power them. So the second one is the second task to compare capabilities is drawing an image based on a text prompt. So for example, if you're familiar with DALL-E 2 recently came out from OpenAI, and it's a model that uses some diffusion techniques to actually produce photorealistic images, or really any images that you kind of aspire to be created.
Extremely high quality, very believable images. It just, they for the most part look like somebody very talented and skilled drew them or generated them or whatever.
Those images on the screen are from DALL-E 2. So a high quality photo of a monkey astronaut is the one on the left that you get. A teddy bear on a skateboard in Times Square is the one on the right.
There's even some nice defocus blur in the background on that one too. It's very, very advanced stuff.
And you can tell it's a little generated, right? Because if you look at the edges of the teddy bear, that just looks a little bit off, so to speak. Like it's a little jagged.
It's punched out a little bit oddly, and also the lighting is just kind of off because you see that kind of around the rim, the lighting is a little bit different.
But in general, the implications of DALL-E 2 are truly incredible. Now, I didn't have a chance to ask Griffin to draw a high quality photo of a monkey astronaut or a teddy bear on a skateboard in Times Square. However, there's a member of our team, Jay Lowe, and I said, hey, could you give me a recent example of maybe
Jay Lowe is a member of your team?
Jay Lowe?
All right.
Jennifer Lopez?
Yeah.
Jenny from the block?
Jenny from the block, also known as JAYLOWE, is a member of the team. And he has a daughter who is a toddler. And I said, hey, do you have any like kind of recent examples of things that you asked her to draw? And so he said, yeah, I asked her to draw me a pretty picture.
It's beautiful.
So on the right, I mean, here's where you kind of eyes in the art, critic lens.
Great use of color there. It reminds me of maybe like a Klimt.
So I don't know. This is where kind of we get to art critic land, but in terms of like what's smarter, I suppose. But the point here is to describe that the quality of photo synthetic images that can be generated from the state of the art of DALL-E is right up there. And I think that
and I will say this, the human generated picture is, I would say, far more creative. It is more imaginative and clever than the machine generated ones, despite being, say, less consistent.
And one thing that I can give an example of is actually showing the, you can actually experiment with generative models today with using, for example, CLIP and VQ GAN, generative adversarial network. So let me actually show some examples of that. Just real quick.
A bunch of really good collab notebooks around that as well. Very fun to play with. Some pretty advanced ones that give you can set a starting image and an end image. You can do all sorts of tweaking and stuff. They're pretty far advanced now.
Here is one of those said notebooks, and some of the outputs of the ability to see what CLIP plus VQ GAN can produce. We asked it to do a raccoon on a tractor, and we said start from a human drawing as an example here. So the human drawing, and then it kind of became this, again, I call it creative. You can make a more verbose prompt, a cartoon raccoon driving a red tractor with big black tires in front of a blue sky and white fluffy clouds. You kind of get this almost like a psychedelic trip.
And one of the things in the prompt there is that pipe, which can you want to briefly explain what that separator does in the context of VQ GAN?
Yeah. So this here is the subject of what you want it to draw, and then the pipe helps it recognize. In this case, we're saying stylistically another consideration that we want the model to take as it generates. So it
basically combines them with the same at the same level. Essentially, it treats them as equal importance.
That's right. Yeah, as opposed to rendered on Unreal Engine being a part of the prior prompt, it's like these are two equally important criteria to maximize, minimize loss as you produce this generative image. So I just put a link to that in the chat.
You see a lot of cool people have figured out a lot of ways to make it give these kind of more human looking or real life looking results as well, like 16K ArtStation or whatever will because of the way the model was trained.
That's right. And then one final test is comparing to GPT-3. And GPT-3 is a generative text model. In fact, instead of going too in depth on GPT-3, especially given the time, I thought maybe showing a demonstration of some of the things that we've created with GPT-3 would be interesting. So at Roboflow, we created a game called Paint.wtf, where there's kind of a funny prompt, and then you can kind of draw in a Pictionary-like interface, and then use CLIP to score how close that prompt was to the image. So what we did is we gave GPT-3 10 prompts. We said these 10 at the top are actually the 10. Best drawing of upside down dinosaur. So we removed the words best drawing of, and that was the prompt. So upside down dinosaur, exploding pig, tattoo of a mailbox, world's most fabulous monster, bumblebee that loves capitalism. We gave it these prompts.
Obviously, I'm the world's most fabulous monster.
Let's see if your photo's at the top, Phil. I don't know.
Spit an image. Looks just like me.
And then we after giving those 10 prompts, we now have GPT-3 automatically create other prompts. So all of the prompts that you see here were actually GPT-3 generated. So a magical telephone booth, a rainbow colored otter, best drawings of a boy on a beach. So all of these are examples of GPT-3 taking our creativity.
A bald eagle with amnesia. That's delightful.
You can get so many creative ideas for writing.
Yeah, it's like that episode of The Simpsons. How do you draw amnesia?
A fireball hitting the ocean, a very comfortable pillow, an angry pelican, an oven full of brownies, scuba gear, business suit, line with lipstick, right? So, and people draw incredible things as they submit. So I highly encourage playing around with Paint. It's just like a fun sort of way to interact with state-of-the-art technology. I mean, I did a blog post on how we made paint, which might be interesting to the folks that are present today, how we built paint.wtf. So I'll drop that in the chat as well.
Definite shout out to Homestar Runner there in the chat. Big fans of Homestar and Strongbad over here.
That's right. Early internet days. So yeah, so I don't know how
they're back, by the way.
Oh. So those are examples of some of the text prompts that GPT-3 can come up with when given other text prompts that are pretty creative. I asked Griffin to give me some text prompts, to which he responded car, which is one of the only words in his vocabulary. So I don't know how you compare that performance to the GPT-3 performance, but text is obviously something that's pretty firmly within the human home court, if you will. So those are kind of the 3 tasks that I thought would be interesting, and showing you all some of the example models. I mean, we talked about the YOLO family of models, we talked about Clip, we talked about DALL-E, we talked about GPT-3. Some things that kind of, some parting thoughts I want to leave you with before we have the giveaway include returning to Francois. I want to give a shout out to Ali Miller from AWS. She was like, oh, if you're giving that talk about machine learning and toddlers, you should look at Francois' tweets, because he's been tweeting a lot about as humans learn, because he recently had a young child. And so you remember we started with one of his tweets from 2017, and now we'll end with one of his tweets recently from 2021, where he says, I never cease to be amazed by the speed at which toddlers learn. Doing a new thing for the first time, then instantly generalizing to infinite variations of it in an infinite number of possible situations. What's crazy about this tweet is I think you could remove the word toddlers and replace it with machine learning, or replace it with DALL-E 2, and you would still have an incredibly coherent, accurate tweet. So I think that's kind of a funny bookend to everything that we wanted to talk about.
I have a story about, humans can learn, people keep saying that humans can learn from a single example. For example, if you just tell a toddler, so you tell that a zebra is a horse with stripes, black and white stripes, right? They will know instantly what a zebra looks like. But I have this funny story. When I first came to the United States, this was like day 2, day 3, right? And in India back then, 20 years back, lettuce was not something, it's not a common thing, right? People knew about cabbage, but lettuce, no, they did not. So my friend, he's ordering at Subway. It is already overwhelming for him because, you don't make your own sandwich back in India. So he finally figures out, and he says that, okay, can I have some cabbage? And this woman, who's really nice, she knew that this guy's fresh off the boat. She says, oh, you mean lettuce? He says, no, I mean cabbage. I want the cabbage. So, it's not necessary that humans would learn from from a single example.
That's great.
It's a great anecdote.
Yeah.
Guy knew what he wanted, damn it.
Yeah. So, I mean, I guess the thing that I'll leave you with is a little bit about, obviously, we're happy to talk about state of the art in all the ways machine learning is advancing and those sorts of things. But can't wait to see some of the things that folks create with Roboflow along the way, and exploring the Roboflow universe. I think that one of the things we might do soon is a competition, and probably announce some of the quality of that competition, and maybe even do a webinar and have that winners of the competition, similar to the OpenCV webinar, talk about things that they've created and open data sets. And these are all ideas that I'm signing Phil up for on the webinar. So we'll see how they pan out after the show. But long story short, very eager to empower all sorts of new applications of machine learning, especially in computer vision, and really appreciate the discussion and questions today. Phil, I know you have a final question to stump our audience with, hopefully.
I do. Yeah, go ahead and unshare your screen if you don't mind. Cool. So similar to last time, I'm going to ask a question based on the slides, and you're going to answer it in the Zoom window. This is open to anybody around the world, unless you have won within the last couple of months. And if you won earlier, please don't answer here. So get ready to answer in the Zoom window. We used a specific book to compare toddlers and machine learning here. What was the title of that book? Oh, Bob Shaw, quick on the draw, you got it. The answer was First 100 Words Bob, please send one email to phil@opencv.org and we'll make sure that you get your, how many Roboflow credits were we giving away, Joseph?
10.
10. Awesome. Thanks so much. Yeah, we've got a couple questions here. Do you want any, one I wanted to quickly ask that you didn't go over here. Joseph, would you like to talk about Roboflow pricing a little bit, if you don't mind? We got a few questions about that during the show.
Totally. Yeah. So Roboflow is free to get started for developers. And from there, you can have, that includes the ability to upload images, manage 1,000 images, 10,000 if you're on the public tier, free training credits and deploy those models, and 1,000 API calls a month of those given models. Now there's a public pricing tier and a private pricing tier. The public tier is very generous. It's hopefully our way of fostering computer vision community. And then the private pricing tier, it depends on the amount of usage that someone needs. And obviously we're very happy to learn about the needs and get someone set up if you're working on a project for your business. But free to get started in either direction. If it's a public project, then high limits, go nuts and contribute to the computer vision community. If it's a private project, very happy to get you set up with the right limits.
And the best way to get started there is to go to roboflow.com/OpenCV. So another question here. I thought this was we're not going to be able to answer this one, I think, very well in the short time available, but I really liked this question, which was, it would be interesting to compare how much energy the Toddler used to answer the question versus the machine. Great question. I don't think we have a good sense of that, but I think that could be a very interesting study to perform at some point.
One thing I looked into actually related to that question is the number of GPU hours it took to train these models. And obviously we've parallelized the training so that you don't just need to wait for one single GPU to finish. And if you were not allowed to do parallel training of the model and of the operations, not only would it be a few $1 million to train this given model, but if you had to do it with just one of the highest grade tier NVIDIA GPU, it would be decades. So I think that if you want to compare what a human is absorbing. Now, of course, the other thing to question is like, well, how many neurons and parameters in the model versus how many neurons and parameters in the brain? But I did go down that rabbit hole of thinking about like the amount of time and learning and experiencing of the world, and how, we're kind of like, maybe that gives an idea to like a classroom of toddlers is maybe a more fair comparison, because we have a classroom of models that have learned. But I did think about this question.
That's really yeah. We could do probably a whole other webinar just about that one question. It's almost philosophical. Yeah, I mean we're past the hour. Satya, you want to take us home?
Yeah, thank you so much, Joseph. Once again, it's always a pleasure to see you on the webinar, and this one was fantastic. I love the notebook, and it's great discussion, and people saw something new. We haven't had this kind of discussion before. So thank you so much. Very interesting talk today. And Phil, as always, thanks for organizing this. And our audience, thanks a lot for joining us. It means a lot to us for you to come here and be in this live session. So we'll see you next week again. Thank you so much.
Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by OpenCV Courses. Learn computer vision and AI from the best at opencv.org/courses. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.